Learning outcome 5.2c, state the work energy theorem. Okay, so we have two work energy theorem. First is the work kinetic energy theorem. Okay, this one. And the second one is work potential energy theorem. Okay, or work done by the force of gravity. Okay, so for work kinetic energy theorem, state that the work done on an object is equal to the change in the object's kinetic energy. Okay, or it state that work done on object. Work done on object, that means work done total. Okay, work done total or work net. Okay, work done total or work net. Okay, so in formula, work net equals to, change in kinetic energy is delta K. Okay, where delta K is kinetic energy final minus kinetic energy initial. Okay, so maybe we can write like this: work net equals to delta K, where work net, delta K is K final minus K initial, and work net is the net force dot S. Okay, and kinetic energy final is half mass times final velocity, and kinetic energy initial is half mass times initial velocity u squared. Okay, and then from Newton's second law, net force equals to ma. So for this one, for net force, we can also substitute as ma. Okay, so it become ma times displacement s equals to half mv squared minus half mu squared. Okay, and we also can proceed this equation by factorize m. Okay, by factorize m, and then we can cancel the m, and then we can have equation v squared equals to u squared plus 2as. Well, that equation is come from chapter 2. Okay, when object move in constant acceleration. Okay, so F net here, F net here must be parallel to the displacement. Okay, must be parallel to displacement. Okay, so this one is work kinetic energy theorem. Work kinetic energy theorem. Okay, work kinetic energy theorem, this one. And then another one is work potential energy theorem. Or we can say that work done by the force of gravity. Okay, another one is work done by the force of gravity. Work done by the force of gravity, or it is also known as work gravitational potential energy theorem. Okay, work gravitational potential energy theorem state that the change in gravitational energy as the negative of the negative of the work done by the gravitational force. Okay, work done by gravity, or Wg, is equals to Fs cos theta. Okay, work done by the gravity is Fs cos theta, where F is the weight. Okay, where F is the weight. Okay, F is the weight because this is work done by the gravity. Okay, work done by gravity actually is the work done by the weight. So weight equals to mg. So we have this one, work done by gravity equals to mg, and s, okay, s is the displacement. Okay, if the object move from h naught, okay, this is h naught, to hf, okay, this is hf, okay, so the displacement is from h naught to hf, okay. So s become h naught minus hf, okay, time cos theta, okay, where theta is angle between the weight, between the force, weight, and the displacement. So they are parallel. Okay, so cos 0 degree. Cos 0 degree equals to 1. Okay, cos 0 degree equals to 1. Okay, so we have, okay, we can expand here. We get work done by gravity equals to mg h naught minus mg hf, where mg h naught is the potential energy at point O, okay, at this point, okay, at this point, okay, and UF is the potential energy at this point, at height final, okay, at height final, okay. So work done by the gravity equals to UF minus U naught, or U initial is the delta U, okay, is the delta U. So we have negative delta U, okay, negative delta U. So it is equals to negative U final minus U naught, okay. Or you may write U naught as U initial, okay. U naught you can write as U initial, okay, UI, okay, just a symbol, U initial, okay. So this is the U initial here, okay, this is the initial position, and this one is the final position, okay. So Wg equals to negative delta U equals to negative U final minus U initial. What is the difference between work kinetic energy theorem, okay, and work gravitational potential energy theorem? Okay, so for work kinetic energy theorem, it states that the work done on an object is equals to the change in the object kinetic energy. Okay, this one. So work done on an object actually is the work done total or work net. So you have to use work net, okay, as a subject. So work net equals to delta K, okay, where delta K is K final minus K initial. So work net is net force, okay, dot S. So you have to use net force or total force, okay, total force that is parallel to the displacement. And then for the work gravitational potential energy theorem, it states that the change in gravitational energy as the negative of the work done by the gravitational force. Okay, work done by the gravitational force. Work done by the gravitational force. So in front of here, or subject of here, is work done by the gravity. Work done by the gravity equals to negative delta U, where delta U is U final minus U initial. Okay. Learning outcome 5.3a, define average power and instantaneous power. Average power and instantaneous power. Okay, so for power, it is defined as the rate at which work is done. So power is work, rate of work. Okay, power is rate of work. Okay, so we have to divide work with time. Okay. Okay, so the average power is equals to work done, delta W divided by the time, delta T, it takes to do it. Okay, so P average equals delta W, where W is work, okay, over delta T. T is the time interval, okay. And then, how about the instantaneous power? Instantaneous power is power at that particular time. Okay, so we can get instantaneous power by using formula P instantaneous equals dW over dt. Okay, where W, work, is equals to F dot S. So we can integrate d dt F dot S, because F is constant. Okay, F is constant, so we have this equation P instantaneous equals to F dot ds per dt. Okay, because S, or displacement, is varies with time t, where ds per dt is v. Okay, is the velocity. Okay, v is velocity or speed, so v equals ds per dt. So we have equation P instantaneous equals to F dot v. Okay, where v is the speed or velocity. Okay, so F v cos theta. Okay. Since the work done in a process involves the transformation of energy from one type or object to another, power can also be defined as the rate at which energy is transformed. Okay? Work done actually is the transformation of energy. So we have equation P average. Okay, from P average equals to work done over time, because work done is the transformation of energy. So power average is also equals to delta E, okay, which is change in energy over delta T. Okay. Power is a scalar quantity. It only has magnitude but has no direction. In SI unit, power is measured in joules per second. Okay, joule per second, and is a given special name, which is watt. Okay, watt W. Okay, so you may use unit for power is joule per second or watt. Okay, both can be used. Okay, and then for practical purposes, a larger unit is often used is the horsepower. Okay, horsepower is not the SI unit for power. The SI unit for power is watt or joule per second. They are equivalent. Okay, 1 watt equivalent to 1 joule per second. Okay, but for horsepower, 1 horsepower is equals 746 watt. Okay, so if the question give you power in unit horsepower, you have to convert to watt first before you substitute in the formula, because horsepower is not SI unit. First, we have to convert to SI unit. Okay, and then you can substitute into the formula. Okay. Okay, thank you class.